All right, y'all. So, like I said, 9.4 logarithmic functions. All right, so a logarithm will come in this form. It'll say log, which is short for logarithm. You'll see a little subscript here. And then, so this is how you'll see your logarithms. This little a is a subscript. That's what we call the base. And the y is what we call the result. So what this logarithm finds when we punch in log with a base and a result, it finds the exponent. So it finds the exponent that the base and in my example, base will be the a. So it finds the exponent that the base was raised to get that result. Okay, so they give me the base, they give me the result. When we punch into log, it finds the exponent, okay? So let me give you a few examples of what I'm actually talking about. Now, we'll say on the calculator, so on your calculator, next to the 7 down there, you'll see a log button. This is for a log base 10. We call this the common log when it's a log base 10, okay? There's another one next to the 4 on the calculator. It's a ln. ln is a log base e. So the e we learned about the other day, the Euler's number, it's the base for a ln. We call this the natural log, and we call this one the common log. So this is your common log, and this one is a natural log. So if you got a log and it does not have a number here, it's automatically a 10, okay? If you got a ln, it's actually a log base e. So let me work a few problems just to get y'all's understanding of these logs, okay? So I'm going to start out with a log base 3 of 9. So let's see, what does this want me to do? They're giving me a base of 3. So what I need to find when I punch in a log base 3 of 9, I want to know what exponent is 3 raised to equal 9. Because 9 is the result of this base being multiplied how many times? So this is going to find me an exponent of what, y'all? How many times would this 3 be multiplied? So here's your 3, your base. We're looking for this exponent that we can put here so that when we evaluate this, it equals that result of a 9 right there.
Is it 3?
Oh, let's see. If we put a 3 there, that would be 3 times 3 times 3. So 3 times 3 times 3 equals actually 27.
Oh. So would it be squared?
It'll be a squared, right? That'll be a 2 there. Because 3 times 3 is 9. So remember, the exponent is telling me how many times to multiply that to get that 9. So that'd be 2 times. So when I punch this on my calculator, it's going to give me an answer of 2. Since 2 is the exponent that we would raise 2 to make 9. Now, y'all, let me show you how to do this on the calculator real quick. Now, remember, on the calculator on the front, I said by the 7 was a log and by the 4 was an ln. Any other base like this has a base 3, we got to use another feature in the calculator. So watch this, the way we're going to punch this up. On the calculator, we're going to hit the math button. And then we're going to scroll down that math button until we find log base. Once we find log base, we'll be able to put this problem in exactly like it looks and get that answer. So y'all, let's go to the calculator. So remember, now see, okay, I got them upside down. The log was by the 7 and the ln is by the 4. I think I said the other way around, but they're right there by that 4 and 7. All right, so to do this one with a log base 3, we got to hit the math button. We're going to scroll down until we find log base. I'm going to hit enter. So the base was a 3, so I would put my 3 in, arrow right, and that result was a 9. So there's my log base 3 of 9. When we hit enter, guess what? We will get a 2 on that one. Now, the first few I'm going to do shouldn't be too bad. I'm just going to knock out a few examples real quick, see what y'all know about exponents. How about this one? What if I had a log base 7 of 1? So what exponent would I raise 7 to turn it into a 1? So that'll look like this. 7 to some exponent equals 1. All right, my chat's lighting up, so I got to look at it.
0.
It is definitely 0. Good job, y'all. Because remember, anything to the 0 power equals 1. So when we punch this in, we will get a 0. Actually, we could make a law about that says no matter what your base is, if that result is a 1, then that will equal 0 every time, okay? No matter what the base is. All right, y'all, what if I did this? Log base 5 of 5. So you got a base of 5. What exponent would you raise this 5 to turn it into a 5?
Would it be 1?
It'll be 1. So if the base matches the result, that exponent, y'all, has to be 1. So you can make a little rule about that. If the base matches that result, that'll always equal 1, okay? All right, y'all, one more. Log of 100. Uh-oh, I did not put a base here. So what do you think the base will be? So remember what I said earlier, remember? Look up top hip here. Right there's
2.
log. Oh, what'd y'all just say?
Will it be 2?
Not a 2. Let me see what my chat's saying.
10.
Oh, I will say this. Good job, Reed. It's definitely like a 10 here, but I think you was getting my actual answer when you said what? A 2, right?
Yeah.
Because if you punch it on the calculator, it's treating that log on the front like a log base 10, and 10 times
That's
10.
what I did. I I put it in the calculator.
That's it. That's cool. So just realize though, if you don't have a number by the log, y'all, it is definitely a base 10, and we can use the log on the very front of the calculator for that. We don't actually have to go through and get that log base stuff, okay? All right, so before we play with our calculator and start evaluating all of these, they have a few graphing problems to look at. Now, we'll say these logarithmic graphs are inverses to the exponential graphs y'all did the other day. So remember, the exponential graph sort of went uphill. So recall exponential graphs. So my exponential graphs we looked at the other day are x and y. Remember, they sort of had a horizontal asymptote crossed over at 0, 1 on the y-axis, and then they went uphill, okay? But they're crossing the y-axis at 0, 1. Now, the logarithmic graphs are inverses to the exponential. So what we're going to do to show you that, we're going to graph one. We're going to graph f of x equals a log base 2 of x. So now we're doing a logarithmic graph. So let me get me a graph started. And I'm going to make me an x and y table. See what kind of numbers I'm going to get before I can make my scale here. Now, here's the thing. X cannot be negative because there's nothing you can do to a 2 to make the result negative. I can't multiply 2 by any exponent that'll make it negative. So my x's cannot be negative. My x's can't even equal 0 because there's nothing I can do to a 2 to turn it into a 0. So when you graph your logarithmics, your x's have to be greater than 0, okay? And y'all, if you punch in like log base 2 of a -4, it's going to give you an error message because it cannot turn a 2 into a -4. So the smallest x I'll pick is a 1. Now, I mean, you could do fractions, but I don't really care about plotting fractions. So I'm going to start at 1. Now, if I put a 1 in for the x, what's it equal? A log base 2 of a 1. What would that give me?
I got a nan.
A what now?
When I tried to put that in a calculator, it gave me not a number.
Or you put log base 2 of x?
Yeah.
Okay, Vita, you got it. It is 0. Remember up here we said if the base, no matter what the base is, if we put a 1 in for that result, we get a 0 for the y. Now, let me show you how I'll punch that in just to get the value. So on my calculator, I would hit my math, go down and grab that base, log base, enter. Okay, my base was the 2, and then you arrow right and put in your 1. So at that point, watch, it will give me a 0. Okay. All right. How about I put a 2 there? I'm looking for numbers that are multiples of 2 to put in for my x. So if I got a base 2, the results of 2, what's that exponent give me? All right, I'm trying to get my chat going. So it's going to be a 1. Remember, if the base matches the result, 2 and 2, that makes that a 1. And y'all, let me do one more. So my next x will be 4. Because I'm looking for numbers that I can get from multiplying 2 times itself. So if I put a log base 2 in the results of 4, what's your exponent? All right, so we're getting a 2 on that, and so good job. All right, so I would do maybe one more. Y'all, the next x I would pick would be an 8. Because 2 times 2 times 2 would get me an 8. So if I put an 8 in there, my exponent is a what? And then we get a 3. Good job. So got me some points. So notice I'm going to draw my x-axis over here. 5, 6, 7, 8. My y, 1, 2, 3, 4, 5, 6, 7, 8. And that's enough. I can't be over here on the negative side, remember, because these are not real on that left side if we try to plug them in, okay? So you cannot put a negative x in there because it does not exist, we say. So look here, 1, 0. 1, 0 is on the x-axis. So up here, exponentials went over at 0, 1. The logarithmics cross the x-axis at 1. Right then, y'all, 2 up, 1, 4, 2. And then over here at 8, I was at 3. So what these graphs will do, since they can't be in the negative x's, they make a asymptote with the y-axis here. They cross over at the 1, and then they just slowly go uphill to the right. So sort of the opposite of your exponential. This is its inverse, okay? So remember them pictures when you graph these. Now, if you was to look on your calculator, so let's actually do it on the calculator. I'm going to go to y equals. I'm going to get my log base by hitting math and going down to log base. Enter. So we had a base of 2 and then x. All right, so I got it in. So let's look at the graph. So y'all, there it is, just like we just drew it. Now watch this table. I'm going to hit second graph. Look at all these negative numbers, even 0. You get an error because I can't turn that 2 into those things using exponents. Now, see, I was picking multiples of 2 so that I could get good numbers like 1, 2. Next would have been 8. What's next? 8 times 2. So 16, I would have got a 4, and so on, okay? Now, you don't have to graph these. They're going to give you 4 pictures. Pick out your 4 pictures, which one yours is, and move on. All right, y'all. So now we're going to actually start evaluating logarithms. So these examples, let me get my camera up. These examples will say find the logarithm. But remember, I could say what? Find the exponent, right? Since that's what we're actually finding. So I want y'all to realize that these logarithms are exponents. So these start at number 4 on the homework. The first 3 were just picking a graph. All right, y'all. Let's see what y'all get. A log base 6 of 1296. So y'all push that in and see how many times I got to multiply that 6 times itself to get that 1296. Oh, y'all didn't even bring them calculators, did you? Okay, chat's starting to light up. All right, good job, 84. Okay, 6 times 6 times 6 times 6 equals 1296. So remember, I'm looking for exponents where that equals that, okay? I mean, another thing you could do, couldn't you just take that 6 and start multiplying it until you got 1296 and then see how many 6s you used, okay? All right, y'all, another one. Let's see what y'all get. Log base 8 of a 512.
3.
3, good job. I'm gonna have to leave my chat open on the side. Y'all getting them answers pretty quick. All right, log base 10 of 1000. Okay, so 3 again, right? 10 times 10 is 100. 100 times 10 is 1000. So that's going to be a 3. All right, I'm going to pull the curveball on you. Log base 3 of 1 over 27. And y'all, you can still punch that in on the calculator. Now, this fraction.
-3.
Oh, what'd you just say?
-3.
-3. So if you got fractions, the exponents will be negative, okay? Negative. When you move things up and down on fractions, it changes the signs of the exponents. So since that 27 is in the bottom, it would make that 3 to the -3rd a rewritten form of that, okay? So just remember, fractions give me negative exponents. All right, y'all do this one. ln of 1 over e. So the ln is on the front of the calculator. And remember, to get the e, you hit second divide. Now, I do know what sign that'll be because that is a fraction, right? So we know that'll be a negative something. So y'all, let me show you how to punch that one in. It's a little trickier. All right, so let me quit this screen. Oh, my chat's getting it. -1. Good job. Y'all hit the ln by the side of the 4 here. Now, if you want to use a fraction, you can hit alpha y equals and enter. And it'll put your fraction there. And do 1, arrow down to get the E, the blue button, and the divide. All right, then when I hit enter, I do get that -1. Good job. All right, how about this? Log of 10. And y'all, guess what? You can actually use the log on front of your calculator. So let me see the chat. Lighten up. So, okay, 1, that's it, right? Remember, that's the base 10, and 10 to the first equals that 10. Log 3 of 3 to the 4th. All right, so on that one, when you put in your log, you'll have your base 3, arrow right, and then put in your 3 and make that exponent 4.
4.
That is definitely a 4. Good job. And y'all, you actually got a property on this. If we got a log base a of a to an exponent, it's always going to equal the exponent. So just like this, if the base matches the result to an exponent, the answer will always be your exponent. All right, so here's one I'm going to have to show you how to put in. They got a log base 5 of a 7th root of 5. So the part I'm going to have to show you is how to do this 7th root. So to do roots that are higher than 3, so to do the root, I got to hit the number in the slot first. That's called the index. So what I would do to do that root right there, I would hit 7, then hit the math button, and I would arrow down until I found a radical with an X in front of it. So if I hit the 7, then hit the radical with the X in front of it, it'll put it in as a 7th root. So watch my steps on this one, okay? So I'm going to my calculator. Let me clear everything off for you. Now, I got to do my log base first. So I'm going to hit math, go get my log base, enter. That was a 5 for my base. Now I've got to put in the 7th root of 5. So remember, you got to hit the 7 first, go to math, and you'll see option 5 is an X in front of the radical. So hit option 5, and look what it does. It makes the radical with the index, and then put in your 5. So Vidi, let me tell you what, you got the right answer, but it ain't in the right form. How about you turning that 0.1428 into a fraction for me? All right, read, what is it? 1/7. There you go. Because when I hit enter, now Vidi, let me tell you what's happening on you right now. You're rounding off still. So go to mode and make sure you're highlighted float. All right, now watch this. I'm going to hit math and enter twice and turn that decimal into a fraction. Good job, Reed. That is definitely 1/7. So that means that the radicals give me fractional exponents. Fractions gave me negative exponents. Radicals give me fractional exponents. All right, y'all, what about this? Log of 10 to the -4th. And that one you can use the log base, or you can use the log on front of that calculator. Uh-oh, y'all, let me get y'all on that. All right, y'all, let's go punch that in. We got what, a log of 10 to the -4th.
Mr. Eugene,
Yes.
how did you turn that into the answer into the fraction again?
All that 0.1428571429.
Uh-huh.
I hit the math button, and the very first thing you see is fraction.
Oh, okay.
So you hit enter on that and then hit enter again.
Thank you.
Okay. Oh, y'all got that -4. Good job. Good job, y'all. Yeah, you punch that in, that's going to give you a -4. And that's going back to this. They're just wanting y'all to realize, y'all, that that's a 10 down there. And the base matches the result to an exponent. The answer is always the exponent, okay? All righty, how about this one? A log of 64 to the 4th. And remember, y'all, I don't want a decimal answer on that, so punch that in and see what you got. In that one, I'd probably go to math and use that log base, okay? Oh, good, 1/3. Because y'all, here's the thing. I'm starting with a 64. I need to turn that into a 4. So the only way to turn a 64 into a 4 would be a cube root. And remember, cube roots are written as fractions, which would give you a 1/3. Okay. All right, I'm going to turn the heat up, okay? Log base 33 of a 1. All right, so y'all should already be putting that answer in for me. Oh, good job.
0.
Good
0.
job. Definitely a 0. All right, so then let me do one like 16. 15 was another easy one. How about this one? ln of the 9th root of an e. So you got your ln on the front. Remember, when you do the radical, do the 9 and then hit math and go get the one with the x in front of it. Throw that e in there and tell me what y'all get. Now, it's a radical, remember, so radicals, I'm expecting a fraction, y'all. Oh, see, y'all are doing good. That is definitely 1/9. So are you noticing the answer is basically these indexes of these radicals under a 1? 1/9 here. Up here we had a 7. That rewrote as a 1/7. Okay. All right, y'all. So then what they start having us do, since exponential and logarithmic functions are inverses of each other, we do conversions from one to the other. So here's the conversion. Log base a of a y equals x. So the log a base with a result equal to my exponent is true. Y'all, this double-headed arrow means if and only if a to the x equals y. So my base raised to the exponent has to equal that result. And that's why I was sort of rewriting them like that when I was explaining, so that you would see how they're related to each other. So what they'll do, they're going to give me exponential equations. I'm going to convert them into the logarithmic equations. And then they'll go from logs to exponential. So this is the logarithmic part. And this is the exponential. So first off, we're going to convert to a logarithmic equation. Now remember, they're going to give me the exponential. So these will be like 17 through 20 or so. So they're giving me 10 squared equals 100. That's the exponential. So for my answer, logarithmic, well, I got to write log first. So my question is, what would be my base? So I'm starting out this way, going this way this time. So what's the base of this logarithm? 10, good job. So that'd be a base 10. Remember, 10 is the base. It's the base of the exponential. That means it becomes the base of my log. The result that I would put next would be 100. Good job. So remember, that's that result. And that's going to equal an exponent of 2. Good job. Good job, y'all. So you're just going back and forth on these, okay? We're not solving them. We're just rewriting them. We got to get good at this kind of stuff because when we do 9.6, we're going to solve equations, and we got to switch back and forth, okay? All right, let's see what y'all write here. 1024 to the 1/5 equals 4. So y'all, you're starting out with a log again. We want the base. Well, we know the base is 1024. So that 1024 will come down here. The result is the 4. That's going to equal the exponent of 1/5. So that basically tells me if I took a 5th root of that 1024, it's going to equal that 4, okay? Now, how about this? E to the negative 2 equals M. Now, y'all be careful in Math Lab when they give you letters. If there's lowercase, keep them lowercase. If they give you capital letters, use capital letters, okay? All right, I need the base of that log. So, okay, I think y'all got the whole thing. So log base E, good job. The result is the M, and that's going to equal the negative 2. Good job. Now, check this out. Since that's a log base E, ain't there another way I could write that? If I wanted to, anytime you got a log base E, you could write that as the ln of M equals negative 2. Remember, I can change the log base E to a ln, and actually up here on the log base 10, we could have wrote that as just the log of 100 equals 2, okay? Because remember, if I write that, it's understood to have a 10, and if I write ln, it's understood to be a log base E. So y'all went one way. Let's see if y'all can go the other way. We're going to convert to exponential. All right, so these will start around 21, okay? Log base 3 of a 9 equals 2. There is my logarithmic. So we're coming up with the exponential. So what is your base? Well, we got 3 numbers, y'all. Which one's my base for my exponential?
Isn't
So
it
it's going to
not?
be the 3.
I mean, 3.
All right, what's my exponent?
9.
Oh, so I got 2's and 9's. Well, remember, this logarithm finds exponents. So the exponent would be the 2.
Ew.
Because remember, 3 squared gives me the result of a 9. Okay, so remember, when it's in log form, your base, your exponent, and then your result. Okay? All right, so y'all get to redeem on this one. Let's see which one I want to do here. I'll do this 22. Log of 0.1 equals -1. So a trick question here, but what's my base? Oh, Victoria, that's my result. Okay, I want the 10. There you go. Since there ain't a base here, remember, it is definitely a 10. All right, now I need my exponent. So that's going to be the -1. Good job. And 10 to the -1 equals a result of 0.1. Good job. All right, y'all, here's one MathLab's really picky about capital and little letters. They got log base m of a little m of a r, capital R, equals a little z. Just remember when you write it in, use capitals and letters, capital letters and lowercase letters. So the base, what's the base? All right, the base is an m. How about the exponent next? What exponent am I putting here?
Is it -z?
All right, the -z. And that's going to equal? Capital R. Good job, y'all. So watch MathLab with the capitals and the small letters, okay? Now, y'all, here's the thing. Once you get around number 25, they actually say use a calculator to find the common logs.
Hey, I got a question. Where's the log button in the math lab?
Say again.
The log button in the math lab?
You write log.
Okay.
You physically got to write it. Now, when you write log, it'll make it, what do you call it, bold. It'll make it look thick and bold. And the ln, I usually use a little l and an n for it. It'll make it bold when you write it, okay? Some people accidentally write capital I and an n for ln, and it won't make it bold, so they miss it because of that. So it makes them bold when they're punched in correctly. All right, so what happens when we got logs of something like this? Now they say approximate 4 decimal places. Which means when you approximate 4 decimal places, you look at the 5th decimal place. If the 5th decimal place is a 5 or greater, you're going to round that 4th decimal place up. If it's 4 or less, you're going to leave it what it was. So look at this. A log. Now remember, common logs are the base 10 logs. They got log of 68. Now, y'all, I'm going to show y'all something here, just to get you thinking a second. Remember, if they don't have a base here, we know that's a 10. Well, what does 10 to the first power equal? All right, y'all, come on. 10 to the first is 10. Okay, good job, Kayla. Now, that's a 68. So I'm going to do the next exponent. What does 10 squared equal? All right, so 10 times 10 is 100. And I'll even do one more. 10 to the third. What is 10 to the third going to give you? So 1,000. So y'all look at here. Here you got 68. That 68 is somewhere in between that 10 and that 100. So if 68 is between 10 and 100, its decimal has to be in between 1 and 2. Does that make sense? Any numbers between 100 and 1,000, their exponents would be 2 point something. Okay? Once I got bigger than 1,000, then I'm starting to get 3 point whatever up to 10,000. So you can almost estimate these. I know this answer will be between 1 and 2. So y'all punch that in the front of your calculator, log 68, and round me about 4 decimal places. So 1.83, so 1.83. Also, I was getting a little bit different than, let me see, let's go punch it in real quick. I was getting a little bit different on the last number. So we did log, put in 68. So it must have been on the rounding. Let's see. So the fourth number is a 5. Oh, you got it right now. Because since the fifth number 0 is less than 5, we don't round up. So we're going to keep that what you got now, 1.8325.
I thought you said if it's 5 or greater, then you round up, and if it's 4 or less, you round down.
Okay, so let me show you back on my screen.
So does it need to be greater than 5?
No, watch this. My fourth decimal spot is, I got an 8, 3, 2, 5 is in the fourth spot. So that means I will have 4 digits when I'm done.
Okay. We need to go 5
So
spots
I'm
over.
looking at the next number, which was a 0.
Okay.
Okay. So yeah.
Okay.
Don't count numbers before the decimal. We're looking after that decimal, okay?
Okay. I was counting my decimal places wrong. I was counting the first decimal as 1.
Okay, yeah, okay. I see what you're doing. So that's the trick on it, okay? All right, y'all, let me flip over. We'll do some more of these. All right, y'all, try this one. Do a log of 167. So remember, that's in between that 100 and that 1,000. So y'all should get me a 2 point something on this one. Since 167 is in between 100 and 1,000. So let's see, I'm getting a 2.222. Good job, that's what I had. 2.2227. Now, did that one have to round up? I can't remember. So we had what, log of 167, we said. And enter. So no, that had a 1 after it, so good job. All right, I got another one here. This will be like 27. Log of a negative 77. So y'all push that in and tell me what we get.
Um, was this a trick question?
Well, no, it's actually in your homework, but you might get a tricky answer.
Okay, well, I got a tricky answer.
What did it
I don't
say?
know how to. What do I do? What do we do with this?
Okay, so let me go back over. So let me punch that in. We got what, a log of a negative 77. So I'm hoping you got something like that.
I got 1.8864907252 plus 1.364376358. I'm sorry, 538I.
Oh, since you got an I on it, that means it's a non-real answer. Now let's fix that. Hit your mode button.
Okay.
Whoops, let me quit that and hit my mode. Go all the way down. Is real highlighted on yours?
Now it is.
Okay, it was on A plus BI, it sounds like.
It was on it was float was highlighted
Okay, I
at
want float.
first.
I want it looking like mine looks now.
Okay.
Float highlighted. Go down and make sure real is highlighted.
Okay.
And then when they're highlighted, just hit clear and then hit enter and see what it does.
Same thing.
Okay, are you using the phone app or the calculator?
The phone.
Oh, okay, so it might actually be giving y'all, if you get imaginary answers like that with the I,
Mm-hmm.
that means this does not exist. And
Okay.
Math Lab will actually give y'all a choice, and we put does not exist. Since those are imaginary, okay? So y'all be careful on the phone apps. If it gives you anything with an I in it, that's not real, so it does not exist in the real world, okay?
Okay. Thank you.
So I finally found something that does different. All right, now these ones will say use the calculator to find the natural log. And that's the LN stuff. Remember, that's the LN, okay? So let's see. I'll do one of these just to see that y'all are getting this. How about a LN 39? Round me out 4 decimal places. Yeah, Nova, when you get that where it says quit screen, that's going to be does not exist, okay? All right, y'all, looks good. 3.6636. Good job. Oh, let me do one like 30. LN, okay, y'all ready? LN of a negative 0.15. All right, does not exist. Good job. So I can't turn 10s into negative 77s. I can't turn little e's into negative numbers, okay? All right, now 31 through 34. The instructions say use to change a base. Well, that's old school terminology. What they want us to do on our calculator is go to the math button, arrow down, and use our log base. Okay, that's old school lingo for use the log base in the calculator, okay? So y'all try this one for me. I'm gonna do one like 31. Now, since these are not perfect exponents, you still got to round these out 4 decimal places. So do me a log 5 of 70. And y'all round me out 4 decimal places. So see, they're getting you used to all the different log buttons on the calculator. The log on front for the common log, the log on front for the natural log, and now the log base stuff. So it looks like I got 6397 on that one also. So 2.63 0.97. There must have been another, it must have been lower than a 5 after the 7. Hang on, I'm trying to get my notes back together. All right, y'all. So the very last thing they have you do, this will be like 35. Last one. So most of these are going to be quick for y'all, though. Punch it in and be done, okay? This last one says graph both functions. So they're giving you f of x equals 5 to the x. They give us an exponential. And then remember, since this is the inverse, they're using inverse notation. And this one says log 5 of x. Now, y'all, we know what these graphs are going to look like. We know what the exponentials look like, right? They sort of come across, go at 0, 1, remember? They come across, and the exponential is going to go uphill like that. We know what the log graphs are going to do. They're going to cross at 1, 0. And remember, they can't be negative, so they're going to come up, and we know they're going to cross over, and then they sort of slowly go uphill as you go to the right. So let's go graph these, because you're going to pick one of the 4 pictures they gave you. So let me show you how to graph both of those. So I'm going to go to calculator. All right, I'm going to go to y equals. Whoops, I got to quit that first. All right, so I'm going to go to y equals. I'm going to put 5 to the x. So 5 exponent x. Then I'm going to go down to y2 and put log base 5. So I'm going to hit math. Go get my log base. Since it had a 5 there. Enter on that. So log base 5. Arrow right. Put in your x. Okay, y'all. So let's hit graph and see what we got. So there was my exponential. Went uphill to the left. And there's my logarithmic going to the right, slowly uphill. So y'all, one picture matches them. Pick that and be done. Now, y'all, let me tell y'all a few things on this. When you're doing Math Lab, and you're putting answers into that where you had to convert them, and you got to put in the base here, you're going to write log, and then Math Lab will have a button down here that looks like a box with a blue box next to it. When you hit that, it'll put up your base. Y'all, when you put the base in, you got to arrow out of that before you put in the result. If you don't arrow up, it'll keep it all down here with this subscript. We want to get out of the subscript and back up and then put in the result. Okay? And then when you do the LN stuff, remember, that is a little L. Okay? But like I said, when you put them in, it'll make them real dark and bold for you. All right, y'all. So I'm hoping y'all see now that logarithms in the long run are nothing but exponents, okay? All right, so let me tell you what's coming up on Tuesday. We're going to get into 9.5. I'm going to do a little bit of support with that one because it goes over exponent rules. And then we do the 9.5 properties of logarithms. Since logarithms are really exponents, we got rules that they follow just like the exponents do. So we're going to go through the power rule for logs, the product rule for logs, quotient rule for logarithms, okay? So that'll be our next class, and that's another important section so that we can do those equations on Thursday, okay? All right, y'all, so that's your work for tonight, 9-4.
All right.
Try to catch all that up before Tuesday, and then we'll get to knock out the last few sections.
Sounds good.